Hello everyone, you're welcome to this video. I remain your tutor, Mr. Life Changer. Here we are going to continue from the previous video. It is expected that you have watched the part 1 of this video to continue with this one, okay? So this is a continuation. So here we are looking at alkanols, the naming of alkanols, okay? So one thing you should note about the naming of alkanols is that the name always ends with OL, all. So continuing from this, we have CH3CH, OH. OH is definitely a branch. Once you see a functional group in a bracket, it means it's a branch. So that means if I want to write this, it's going to be CH3, CH, then we have OH, then CH2, CH2, then CH3, okay? Now since it is OH and is in position 2, it's going to be 1, 2, 3, 4, 5. 5 means pentan 2 all, because OH is in position 2, so that's why it's called pentan 2 all. I hope this makes sense. Now the answer is A. Now, but how about if you have a substituent? Assuming I had a substituent like this, let's say the substituent is chlorine. It means that this is going to be 1, 2, 3, 4. It's going to be 4 chloropentan2-ol. Don't forget, I've told you before that once there is a functional group, you don't consider any other substituent. The functional group, the number of the functional group determines the numbering of the rest of the substituents. I hope that makes sense, right? Okay, so now, but I also want to add something here very briefly, that this type of alcohol is called a secondary alcohol. This is, by the way, this is me now doing gossip. Now we have primary, secondary, tertiary alkanol. Now for you to know a primary alkanol, once the carbon bearing the OH has only one hydrogen, that's secondary. If the carbon bearing the OH has two hydrogens like this, okay, this is primary, like ethanol. Once the carbon bearing the OH has only one hydrogen, but the rest is occupied, then this is a secondary alkanol, okay? But once the carbon bearing the OH has has no hydrogen, just like this, okay? So this one here is tertiary. So that is, by the way, secondary, primary, tertiary alkanol, okay? I believe that can be helpful. And usually questions that come out there, they ask you, how do you differentiate them? There's a reagent called Lucas reagent. It's used to differentiate them in the laboratory. I'm going to be doing a video on test for organic compounds. It's a long way. So for this one says identify the correct IUPAC name for the compound. So this is a compound. It has two OH groups. So anytime you see two OH group, it means diol. So, and there are two carbon here, so it means it's going to be ethan 1,2-diol, okay? Because the 2-ol are in two different, are in position 1 and position 2. So that's it. Nothing much to be said here. Let me just draw something. Let's say you have CH3, and you have OH. If you're asked to name this, I know some of you are going to wonder, you're going to say the longest chain is ethyl, but no. The longest chain here is 1, 2, 3, propyl, or prop. So the parent name is going to be propan 2-ol, because OH is in position 2. Methyl is also in position 2, so 2-methyl propan 2-ol. That is me just adding that. Now this one has to do with halogens, halogenoalkanes, and actually we call them alkyl halides or haloalkanes. So in this case here, when you see a structure like this, you can write it as CH3CHBr, then you have CH2, then you have CH3. You see that? So the longest chain is 1, 2, 3, 4, which is butane. and bromine is the second carbon atom, so that is 2-bromo-butane. That's quite straightforward. Now for number 10, we have this CH2Cl, CHBr, CH3. This is still the same. You have CH2, then Cl here as a branch, then you have CH, then you have Br as a branch. You see, substituents are usually represented as a branch. Then you have CH3. So in this case, the longest chain is still 1, 2, 3. So that's propyl. Propane. This is propane. So this is 1, 2. I must count from here, because if I count from here, this is 1, 2, 3. 1 and 2. If I count this other way, it's going to be 1, 2, 3, which is 2 and 3. So 1 and 2 is smaller. But remember, bromine always comes before chloro. Don't forget that in alphabetical order. So that means I have to put 2 bromo first, then 1 chloro, 2 bromo, then 1 chloropropane. Very important. 2 chloro, 1 bromopropane. So okay, 2 bromo, 1 chloropropane. A is the answer to that question. You know, it's very confusing. One may want to choose D, but no, it has to be alphabetically. B comes before C. Don't forget that. Now the next one now has to do with naming of alkanals. Now the way you know an alkanal always ends with CHO. That's how you name the alkanal, and that's you can write it like this as the structure. This CHO, this is how the structure is. So, and the numbering of alkanal starts from that CHO. So 1, 2, 3, 4. This is called butanal. So even if I have CH3, CH2, 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 CHO, and let's say here not CH2 now, let's say here I have CH, then CH3, the name of this compound is going to be 1, 2, 3, 4, 5. 4, that means 4 methyl. Methyl is in position 4. Then pentanal. You know, it does not, you don't need to say pentan 1-al, no, because it always ends with CHO. So just pentanal. Okay. Now the next one, number 12, is we have dialdehyde, but I'm not going to bother you with this. It's not necessary for you. Now for alkanones, if you want to name alkanones, how you know an alkanone that is a ketone is CO. That's how you know a ketone. It's either you just see a CO like this, or you see C double bond O this way. Then here you have alkyl group, and here you also have alkyl group going this way. Okay. So the way to name this, don't ignore the 0, the O, just name it as a straight chain. You have 1, 2, 3, 4, 5. But don't forget, this CO is in position 2. So it's going to be pentan 2-one. Yeah, that's how it works. Pentan 2-one. So you have butanone or butan 2-one, and so on and so forth. So if I have CH3, COCH3, this is called propanone. If I have CH3, COCH2, CH3, this is called butanone. Or you can just say butan 2-one. The reason why you can just name it as butanone is that even if the CHO is here, it is still butanone. Now CH3, CH3, CO, CH2, CH3. This one, the longest chain is simply 1, 2, 3, 4, 5. Remember, ignore this. It's part of it. Okay? So 1, 2, 3, 4, 5. That means pentan 3-one, because the functional group is in position 3. I hope that makes sense. Now look at this one. We want to name this. If I write this, I should have CH3, CO. Remember, I can still write it like this, CO like this. Then CH, you have your CH3 this way, and you have CH2, CH3. The longest chain is this, which is 1, 2, 3, 4, 5. So that is pentan. So that's pentan 2-one. But if you notice, there is a substituent attached to it, which is methyl, and that methyl is in position 1, 2, 3. So that would be 3-methyl butan 2O. I hope that makes sense. Then the next one is carboxylic acid. Now, how you know a carboxylic acid? It always ends with COOH. So the name is always oic acid. So here there is a branch CH3. So I can write this as CH3, CH2, CH. CH3 is a branch. Then now COOH. You see? So I must start from here, just like alkanal. My numbering must start from here. 1, 2, 3, 4. 4 means butanoic acid. You see? Oic acid, buta, 4. Then 1, 2. The substituent is methyl, so 2-methyl butanoic acid. I hope this makes sense. I hope this makes sense. So if this guy was here, it would have been 3-methyl, you see? And so on and so forth. So even if I have CH3, 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 then COOH, in this case now the longest chain will be 1, 2, 3, which is propanoic acid. Okay, and there are, if you notice at position 2, there are 2 substituents, which is 2,2-dimethyl, because the dimethyl propanoic acid. That is by the way. Then in a case where you have 2-COOH, you call it dioic acid. So like in this case now you have 1, 2, 3, 4. So this is butane, because it's 4, then dioic acid. That's how it works. The answer is A. That's how you name such. Okay. Then in the case of esters, very important. Now for esters, how you know ester is that COO separates 2 alkyl group. Just like alkanones, it is CO, but in the case of esters, it is COO. And the way you name this compound is that you name the alkyl part first, the part after the COO, then the rest. Okay, because it is a derivative of carboxylic acid. So this name here is called ethyl. So I'm going to say ethyl. Then the rest is 1, 2, 3 is propanoate. You see, so ethyl propanoate. And usually, this is now for exam questions. This is me doing amebo. Usually, ethyl propanoate comes from, the ethyl comes from ethanol. The ethyl part comes from alkanol. Then the propanoate comes from propanoic acid. The reason I'm saying this is that you might be asked, what is the product of ethanol and propanoic acid when they react? The answer is ethyl propanoate. The ethyl from the ethanol, the propanoate from the propanoic acid. I hope this makes sense. I really do hope this makes sense. Look at another example. Let's say CH3, then COO, CH2, CH2, CH3. I mentioned after the COO you have this 1, 2, 3, that's propyl. So I'm going to say propyl, then this is just 2, 1, 2. So propyl ethanoate. So propyl ethanoate. If I want to know the source of propyl ethanoate, propyl comes from propanol, remember, from the alkanol. Ethanoate comes from ethanoic acid. So that means propyl ethanoate comes from propanol and ethanoic acid. I hope this makes sense. Let's see another one. HCOOC2H5. It looks somehow, but very easy. After the COO, what you have here is ethyl. So it's going to be ethyl. Then here you only have 1 carbon. So that's 1 carbon means meta. So this is ethyl metanoate. That's the name of that compound, ethyl metanoate. Remember, esters are also called alkanoids. And if you want to know where it comes from, ethyl comes from ethanol. Then metanoate comes from metanoic acid. This is very interesting. Very interesting. Okay, so that now leads us to number 19. This one now has to do with amine. Now the way you name an amine compound. Now first of all, I think what is most important for you in your exams, especially for those of you writing JAMB, is to know the difference between a primary amine, a secondary amine, and a tertiary amine. The same way you know a primary alkanol, a secondary alkanol, and a tertiary alkanol. Okay? Now, this is what you should know. A primary alkanol is NH2. That means 2 hydrogens. The nitrogen has 2 hydrogens. So this is a primary. This is primary. And the name of this compound is 1,2,3. It is propylamine. It is propylamine. You see that? Now, this one here is secondary because the nitrogen has only 1 hydrogen. And it has, if you notice, it has 2 ethyl attached to it. If I want to write this in full, it should be CH3, CH2, then NH, then CH2, and CH3. If I want to write it in full. So how you name this is N, you must have N. N-diethylamine. That's what it means. N-diethylamine. Then a tertiary amine should look like this. CH3, CH2, then N, CH3, then CH3. Something like this. No hydrogen. The nitrogen does not have any hydrogen. That's what makes it tertiary. So the first one is primary, the second one is secondary, and the third one is tertiary. And that is how to name it. Ethylamine, propylamine, butylamine, and so on and so forth. Where you have secondary, you should have N like this in naming it. And where you have tertiary, you should have NN in naming it. Like this one now is going to be NN. Then this one should come before alphabetically. Ethyl, then dimethylamine. Yeah, that's how you name secondary and tertiary amine. That's by the way. Then finally, amide. How you name amide is amide. So 1, 2. So this is ethanamide. Okay, that's how you name it. So you have ethanamide, propanamide, butanamide, and so on and so forth. Okay, that's very important. And I also want you to note that amide also has primary, secondary, tertiary. How you know an amide is CONH2. That's how you know amide. Amine is just NH2, but amide has CO attached to it. Please, I want you to take note. CO. This CO, the name actually is called carbonyl. So in case you are asked, CO actually means carbonyl group. But when it is attached to NH2, it is called amide. AMIDE. Very important. So if I have CH3, CH2, CO, then NH2, this one here is going to be propanamide. And it is a primary amide. Primary. It is a primary amide because the nitrogen has 2 hydrogens. But in this case now, it is a secondary amide because the nitrogen has only 1 hydrogen. Okay, so please note that. And if I want to name this, it's going to be, I name this first, which is methyl. Then I go 1, 2, 3. Propanamide. Okay, so that's how it works. Very easy. Then I'm going to end with this one, benzene. In the case of benzene, now benzene is drawn this way, or like this, or C6H5. Once you see C6H5 attached to anything, that is benzene. So the name of this is methyl. This is methyl benzene. So that's what we have there. Okay. And so on and so forth. Like this one, even though this one is not like that, you call this benzoic acid, and so on and so forth. I don't want to go too far here because I've spent a lot of time in this video, so I may make extra video, but I think this is already very helpful for what you'll be needing in your exams. Okay, so thank you very much. See you in my next videos. Okay, please don't forget to share, like, comment, so I can know our progress reports. Thank you.